Hello guys, welcome back for another question from inverse trigonometric functions, and this is a proving question. Let's see what do we have here in this question. So we have a term on the left hand side as tan inverse 63 by 16, and on the right hand side we have sin inverse 5 by 13 plus cos inverse 3 by 5. In this question we have to take a slightly different approach to the approaches that we considered in the previous questions or in the other questions. In the other questions we generally solve our LHS, but in this question we are gonna solve our RHS first, as we know that merging two terms is easier than breaking a single term into two terms. I mean, if we take our LHS as the operating subject, operating term, tan inverse 63 by 16, if we take this thing as operating term, it's pretty difficult to break it into two different terms. But if we take our RHS as the subject or the term or the object, we can easily merge these two terms and solve the question further. So let's directly deep into the question and without wasting any time. Okay, so the first idea that we get from here is that we have to convert sin inverse and cos inverse both the terms into tan inverse. These two terms have to be converted into tan inverse, and then we can apply our formula tan inverse x plus tan inverse y. I hope you are getting the idea. So let's take the first term. Our first term is sin inverse 5 by 13. So how do we do that? I actually prefer the triangle approach. What do? We take a right angle triangle. Let me draw it properly. Our triangle just got distorted. Okay. What do? We take a right angle triangle. This is a right angle triangle, and we have sin inverse 5 upon 13. That means this is 5, this is 13. So by Pythagoras theorem, this becomes 13 square minus 5 square. That means 169 minus 25, which is actually equal to how much? 12, I hope. Yes, it's 12. So this side becomes 12. So we can directly see that our 10x is equal to 5 by 12, or x is equal to tan inverse 5 upon 12. We directly got sin inverse 5 by 13 as tan inverse 5 by 12. Let's see how they have done. Yes, I think they followed the same approach. What they did? They first considered sin inverse 5 by 13 as x and took sine on the both sides here and wrote sin x is equal to 5 by 13. Then they find out cos x is equal to 12 by 13 by the formula of sin square plus cos square x is equal to 1. They applied that formula and they got cos x is equal to 12 by 13. Now what they did? They took tan x is equal to sin x upon cos x and they got their answer as 5 by 12. Yes, they are getting the same answer. So we can say that our approach is right. So we get something as sin inverse 5 by 13 is equal to tan inverse 5 by 12. Now moving to the next term, cos inverse 3 by 5. Let us move to the next slide first. Okay, so now we have cos inverse of 3 by 5. So how do we convert this thing into tan inverse? So let me show you this thing with triangle approach again. This is a right angle triangle. Cos inverse 3 by 5, that means this is 3, this is 5. So this side by Pythagoras theorem will be 25 minus 9. That makes it 16. Root 16 is equal to 4. So cos inverse 3 by 5 directly got converted into tan inverse of 4 by 3. Did I make some mistake? No. Yeah. So cos inverse 3 by 5 just got converted into tan inverse 4 by 3 here. They have made a mistake here. This is wrong. This must be 4 by 3. Moving further, we get our RHS as sin inverse of 5 by 13 plus cos inverse of 3 by 5, replacing the corresponding sin terms into tan terms and the cos terms into again tan terms. We can replace sin inverse 5 by 13 by tan inverse 5 by 12 as we did earlier, and cos inverse 3 by 5 into tan inverse 4 by 3. Now I hope you all remember the formula of tan inverse x plus tan inverse y. We are gonna apply that formula over here. The formula I am talking about is this one. Sorry. Yes, this one. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, where our x is 5 by 12 and y is 4 by 3. So, yeah, we got tan inverse of 63 by 16 and that is equal to LHS. So, answer just got solved. We have LHS is equal to RHS. I hope you got it. Thank you.